We're going to look at some additional examples of solving radical equations. And those would be equations that have square roots, cube roots, fourth roots, etc. You'll notice that these examples should look very much like the problems you're solving in your assignment. So if there's a particular equation that you're struggling with, skip through the video till you're at the problem that's just like yours, and hopefully you can follow along with your steps comparing them to mine. All right, well, let's start at the beginning here. In number one, we should have a square root of a quantity. Here I have square root of 2a plus 12 equals 8. And I'm looking at my square root, and I notice that underneath it, there's a 2a plus 12. But other than that, there's nothing in front of the square root, and there's nothing after the square root before this equal sign. So solving equations like this are very direct. We do not have to do any extra work. We just need to cancel the square root so that we can start solving for our variable. And in all of these cases, a radical sign is canceled by an exponent. And for square roots, that exponent is always 2. So to cancel the square root, we have to use this exponent of 2. We're going to raise the left side to the second power. What happens is the square root sign gets canceled by this 2, and we are left with 2a plus 12. So 2a plus 12. And what we have to remember to do is, yes, it was nice to get rid of the square root sign, but we also have to balance our equations. So if we're going to square the left side, we must square the right side. And so over here, we get 8 squared, and that is 64. So what we've done is we've rewritten the equation without a radical. And now we can just go back through our solving equation steps from Algebra 1 to solve for a. And in this case, we always subtract before we divide. So we'll subtract 12 on each side. And we get 2a equals 52. And then when we divide by 2, we get a equals 26. Okay. And part of the instructions here are to check for extraneous solutions, extra solutions that don't actually work. So we do have issues sometimes when we cancel the square root, for example. We do that so we can solve for the variable, but sometimes that answer doesn't actually work with the square root that we started with. In this case, we're going to be okay. We plug in 26 up here. 2 times 26 is 52, plus 12 is 64, and the square root of 64 actually is equal to 8, so we're okay in this scenario. But we might see a scenario today where that doesn't work. All right, so let's jump over to the second example here, 3y plus 7. So here's our square root, square root 3y plus 7, and you notice there's a minus 4 after it before the equal sign. And we want to get rid of that minus 4 before we cancel our radical. So here, very easy step. I'm going to add 4. And I'll add 4 on the right side of my equation as well. And then we get the square root of 3y plus 7 equals whatever this is. 3 plus 4 is 7. And now we have a setup very much like we did in the last example. We have the square root of 3y plus 7. So our variable is underneath this square root. So to cancel the square root, we square both sides, meaning we'll square both sides here. And we'll get 3y plus 7 equals 49. Okay, so we canceled our square root, and after that, some simple steps afterwards from Algebra 1. We can subtract 7, and that'll give us 3y equals 42. And divide by 3. Maybe we get a fraction, maybe we don't. In this case, 42 divided by 3 is just 14. Okay, and we can plug that back in. 3 times 14 is 42, plus 7 is 49. Square root of 49 is 7, and 7 minus this 4 gives us an answer of 3, which is what the equation is equal to. So again, this solution works. Okay, so let's look at a couple of other examples here. Number 3 also has a square root. In this case, we have 2 numbers that we have to deal with. So the square root is just here. It's the square root of x. And there's nothing else under that sign. So the first things we have to do are get rid of the of any values that are not underneath the square root. So in this case, there's a 4 in front and a -5 afterwards. And when we solve equations, we always save dividing for last. So to cancel this 4, we're going to need to divide. So let's not get rid of that yet. Let's go ahead and cancel the -5 to keep things simple. So if we add 5 on the left side and the right side of your equation, you'll get 4 times the square root of x equals 24. And we're getting a little bit closer. We still need to divide by 4 to cancel this here. So we'll divide on the right side. Now we have the square root of x equals 6. And because over here now all we have is the square root of our variable, now we're ready to cancel that radical with an exponent of 2, which means we'll use exponent 2 here. And we get x equals 36. Okay. And again, we can plug that back into checks. Square root of 36 is just 6 times 4 is 24 minus 5 equals 19, which is what the equation says. Okay, so that solution is also good. Let's move on to another example here. And on this one, we are increasing the root instead of square root. It's now fourth root. The steps are still going to work the same. We're just going to use a different exponent to cancel. So the first thing we determine is, what do we have? We have the fourth root of 2x plus 6, and we notice there's a -3 after that before our equal sign. So we need to get rid of that -3 before we get started. So to cancel -3, just as we always have, we will add 3 and add 3. And we get the fourth root of 2x plus 6 equals 3. And that's as much as we can cancel via addition and subtraction. We can't cancel the plus 6 because it's actually underneath the fourth root. So that's why we're talking about how to solve these equations. If I have this fourth root of 2x plus 6, to solve for x, I need to get rid of the radical. In order to do that, we just need to use the correct exponent. And for fourth root, the exponent's 4. So I'll use an exponent of 4 on both sides. So over here, we get 2x plus 6 because the fourth root cancels with the exponent of 4. On the right side, 3 to the fourth would mean 3 times 3 times 3 times 3. Or you could grab a calculator and put 3 to the fourth. And that should give you 81. Okay. So now we're just back to how we were. We need to solve for this. So we subtract 6 and subtract 6. And we get 2x equals 75. And divide by 2. We can try to reduce this, but 75 over 2 is already reduced. We could use a decimal, but in our assignment, we want to keep our answers as fractions. Do not use mixed numbers. Let's just keep the improper fraction, 75 over 2. And we can check this answer. It's not necessarily as simple to check because we have a fourth root, but maybe a calculator could help us in that regard. If we take 75 over 2 and substitute in for x, 2 times that fraction is just 75. And 75 plus 6 is 81. And the fourth root of 81 is 3 because of what we saw earlier. When you multiply 4 3's together, you get that number 81. So the fourth root of 81 is 3, minus 3 is 0, which is what the equation equals. So again, this solution is working out. All right, so let's go to our last 3 examples. And out of all of the examples we're going to look at today, number 5 actually is going to have the most work to it and maybe some things we need to check. So here's what's going to happen in number 5. You notice we have 2 x's written in the equation. One of them is underneath the square root sign and one is not. And that's really what's going to cause us a little bit of an issue here. So the first thing we need to do is kind of like we did in all the others. Let's get the square root by itself. So if you look at your square root here, it's the square root of 4x minus 7. And outside of that square root, after that square root, we have a plus 3. And so what we want to do is we want to get rid of that plus 3 on this side. So we'll cancel over here by subtracting, meaning we'll also subtract 3 on the left side. And what we get is x minus 3 equals the square root of Let's try it again. Square root of 4x minus 7. And now we're at that point where, okay, we have a square root. There's nothing after it. There's nothing before it. We need to cancel it. And to cancel square roots, we use an exponent of 2. Okay, so if we do that over here, notice we don't just put an exponent of 2 on the x and then 1 on the 3. That would make life pretty easy, but it's doing the same thing on each side. You raise the entire right side to the second power, so we raise the entire left side to the second power. And in this setup, remember x minus 3 parentheses squared means that you have those parentheses twice. And this is something we've seen before. We just haven't had to use it in this regard. So you have those parentheses twice, meaning we're actually supposed to multiply those out through distribution. Over here, though, pretty easy. The square root cancels with the exponent, and so we just get 4x minus 7. Okay, so this is where the work starts getting involved on this one. We need to multiply on this side, so let's go and do that. Let's take this x times the terms over here. So x times x is x squared. X times minus 3 is minus 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9 equals 4x minus 7. Simplify a little bit over here. We have the two terms in the middle that combine to a negative 6. So we have x squared minus negative 6x plus 9 equals 4x minus 7. And this is a polynomial equation of degree 2. This is a quadratic equation, so we need to make it equal 0 in order to solve. So we need to cancel this 4x over here. So I'll subtract 4x on each side of the equation. We also need to add 7, because by doing those two things, we get 0. Okay, so if we add 7 on the right side, we'll add 7 on the left side, and we get x squared minus 10x plus 16. So some things we should remember when we solve polynomial equations is the degree, in this case 2, tells us how many solutions we have. So if our degree is 2, we should have 2 solutions. How can we solve these? A variety of methods. You could type this into a graphing calculator and see where it crosses the x-axis. There are 2 locations. Hopefully they're nice numbers, integer values that we can work with. We can use quadratic formula to get the 2 solutions, or we could factor by split the middle. And factoring isn't that bad. Anytime you have a 1 in front of x squared, we know that our 2 factors have to start with x, because x times x gives us that x squared. So actually this one is a little bit simpler because of that 1x squared in the front. So we just need to figure out what 2 numbers go in these parentheses. What 2 numbers are going to multiply to this positive 16 and add to a negative 10? Well, to start, if we're going to multiply to a positive, the 2 numbers have to have the same sign. And so they're either both positive or both negative. And if they're going to combine to a negative 10, they both need to be negative. And so let's think about numbers that could multiply to 16, 1 and 16, 2 and 8, 4 and 4. Out of all those, which ones would combine to that 10, that negative 10? And that would be our minus 2 and our minus 8. So x minus 2 and x minus 8. If you multiply those together, you're going to end up getting x squared minus 10x plus 16 as your final result. So these are the 2 factors that we'd get. And to solve by factoring, as we have done before, we set each factor equal to 0. So we get x minus 2 equals 0, and x minus 8 equals 0. Which very quickly here, we add 2, and you get x equals 2. We add 8, and x equals 8. Okay, so 2 solutions instead of 1, which is fine. That can happen, and there's not necessarily anything wrong with that, but it is good to check our solutions here. So if we go back to our original equation, if we check the 2, so we'd substitute 2 in for each of our x's. And what happens when we do that? We would end up getting a 2 here in the beginning. And on the right side, we'd get the square root of 4 times 2 minus 7 plus 3. And the issue here is going to be that 4 times 2 is 8, minus 7 is 1. Square root of 1 is just 1. Plus 3 is, well, 1 plus 3, that's 4, which doesn't equal 2. And so that means that this solution of 2 is not actually working with our radical equation. The right side gives us 4, and it was supposed to equal 2 in the end. So we can't use an answer of 2 in this case. So let's check the 8. Does the 8 work for us? Well, same steps. Okay, so let's try 8 anywhere I have the letter x. So 8 equals square root of 4 times 8 minus 7, and then plus 3. And here's what's going to happen here. 4 times 8 is 32, minus 7 is 25. The square root of 25 is just 5, plus 3. 5 plus 3 is 8, which is what the equation is equal to. So this answer of 8 seems to be working. We're getting a true statement after using that solution. So 8 is a keeper, 2 has to go. And so what we recognize is that we have an extraneous solution down here. 2 will not work. And so we do not keep it. It's an extraneous, which again are just solutions that we get after we cancel the radical, but our radicals have limitations. For example, we can't take the square root of a negative value and get a real answer. So it's always good to check our answers. Sometimes they'll work. Most of the times they will. Occasionally, though, we do get that result. So out of the 2, we'll keep the 8 as our solution. Okay. So let's look at the last couple. Number 5 was pretty bad, but the other 2 are actually not bad at all. So here it looks terrible because each side has a square root. But you notice on the left side, that's all we have. We just have the square root of something. And for the right side, it's the same thing. We have the square root of 1 minus 3x, but there's no number before the square root. There's no number after the square root. And so while it looked bad at first, if we think about it, to cancel this square root, we would use an exponent of 2. To cancel this square root, we'd use an exponent of 2. And what's going to happen? Well, the square root cancels on the left side, and you just get 3 minus 2x. The square root cancels on the right side, and you just get 1 minus 3x. So while it looked intimidating because we had 2 square root signs, in reality, they both canceled at the same time, and we just get an equation that we've seen in the past. Let's solve for x. So we could add 3x on both sides of our equation, for example, to cancel this one and to combine with this one. So that's going to give us 3 plus 1x, or just 3 plus x, equals 1. Subtract 3 to cancel this, and we just get x equals negative 2. So actually looking at that wasn't much work at all. So a little misleading. Looked like it was going to be complicated, ends up not being. If we check our solution here, 3 minus 2 times x, if we're going to use an x value of negative 2, that's going to be 3 minus 2 times negative 2, which ends up being 3 plus 4. So the left side gives us the square root of 7. And the right side, let's see if that ends up being the same. We use our negative 2. 1 minus 3 times negative 2 would end up being 1 plus 6, which is also the square root of 7. So this solution is good. We'll keep it. So don't be afraid of a negative answer. Sometimes if we have the right setup, those will be okay. All right, last scenario. We have the cube root this time. We haven't seen a cube root yet, but it still works the same as the rest. So this last one with the cube root, we notice again, we have the radical here, and this is the cube root of 6x minus 5. And there's a plus 3 after that, before the equal sign. So like we have in the other equations, we need to get rid of this plus 3 before we get started. So let's cancel that 3 by subtraction. And we get the cube root of 6x minus 5 still equals -1. And now we're at that point where we have our radical here, and there's no number before the radical or after. And so we cancel. And again, all of this is based on what exponent we're going to use. For cube root, we use the exponent of 3. And that's what we need to make sure we use on the right side as well. So that we really do need to put focus there. We know that the radical is going to cancel, but let's make sure we're using the right exponent, because that could change what we get on the other side of the equation. So yes, the radical cancels here and we just get 6x minus 5. But making sure we get the right solution over here, the right number over here, that exponent is going to matter. In this case, -1 to the third, remember, would mean -1 times a -1 times another -1, which ends up being just -1. And now we solve. So we add 5 on each side to cancel here. And we get 6x equals 4. Divide by 6 on each side of our equation. And we get x equals 4 over 6, which does reduce. You can divide both of those values by 2, and we get x equals 2/3. We go back and check our solution. Not as easy as it is with square roots because we're more familiar with square roots, but a calculator could help us. Let's use 2/3 for x up here. That is, sorry. 6 times 2/3 is 4. 4 minus 5 is -1. The cube root of -1 is okay. We can actually take the cube root of a negative. Cube root of -1 is -1, and -1 plus 3 is 2, which is what the equation was equal to. So this solution of 2/3 is good to go. Okay, so again, use these examples to help you out. I hope they do offer some clarity. Make sure in your work you're showing steps pretty similar to mine, and let me know if you have any questions.